It turns out that the capital asset pricing model, while having a fundamental impact on the theory and practice of finance, is not the only model out there. There's a number of other models that you should be familiar with that we go through in much greater detail in the second year course in investment and portfolio management. The first model that's detailed in the lecture notes is called the so-called black CAPM. And this is named after the inventor of the model, Fisher Black, who published a very important paper in 1972 on this model. You might recollect that Black also was the co-inventor of the famous Black-Scholes formula. Now, the model of Black is similar to the capital asset pricing model in that there is one measure of risk, the beta. The main difference between Black's model and the Sharpe model is that Black's model does not assume that a risk-free asset is available to investors. So it turns out, in terms of our mean variance style of analysis, that if you recollect, we introduced a risk-free asset that simplified the problem in terms of choosing a portfolio of risky assets. When the risk-free asset was introduced, then only one portfolio turned out to be optimal. And that was the portfolio that was the tangency on the frontier. And everybody would lever up and down this particular portfolio depending upon their risk aversion. The Black model doesn't introduce the risk-free rate. There's no risk-free rate there. And Black argues that people invest along the efficient frontier, and any combination of efficient portfolios leads to another efficient portfolio. So the weighted combination of all of the efficient portfolios in the market turns out to be the market benchmark, which is also an efficient portfolio. And the formula for the Black CAPM is very similar to the formula for the Sharpe-Lintner CAPM, where we've got now an excess return equals the beta times the risk premium. The only difference is that the excess return is measured with respect to not the risk-free rate, but with respect to a portfolio that's got exactly a zero beta. Now, in the Sharpe model, the risk-free has got exactly a zero beta. In the Black model, there exists some portfolio out there that can be constructed to have exactly a zero beta with the benchmark. So that's the another model that's of use. But what I want to focus on is not the Black capital asset pricing model, but the multi-beta asset pricing model. And this is sometimes referred to as the arbitrage pricing theory, which was invented by Stephen Ross in 1976, and sometimes called a multi-beta or multi-factor capital asset pricing model. And certainly it's the case that William Sharpe was very much involved in extending his model to the multi-beta context in important papers in 1982. And also there's some papers that I would refer you to in my second year course, one by Robert Merton in Econometrica in 1973, and the other by Long in the Journal of Financial Economics in 1974. All of these papers have in common a multi-beta type of asset pricing model. So let me give you the intuition. I'm not going to go through the derivation of these models. I just want to give you the intuition of the models, and these are models that are used in the second year elective courses. So first let's talk about a multi-beta CAPM. The first thing is, why do you want to go to a multi-beta CAPM? Why not use the simple Sharpe model that's rich in intuition, rich in economic foundations? Well, there's a couple of reasons. First, it seems, how should I phrase it, rather heroic to think that we can summarize all of the characteristics that we need to know in terms of generating expected excess returns in one number, the beta. This one number completely characterizes or completely differentiates one security from another security. Remember, the premium, the risk premium that's associated with beta is common across all assets. So the only difference is the beta. So I can completely determine the difference between two securities by looking at the difference in the betas. So that's a lot to ask for in terms of a model. Remember, economic models are designed by construction to simplify the world. The world is too complicated for us to really understand how everything works. So we struggle to create these simple economic models that take a complex situation and make them understandable. And that's exactly what the capital asset pricing model does. It takes a highly complex situation and simplifies it to a single number, the beta, and of course the risk premium. Now, as is true with any economic model, you give me enough data and I can reject that model. It makes sense because with enough data, and given that I know that the model is a simplification of the world, given I know that, with enough data, I should be able to reject the model. So by rejecting the model, it might be I find a number of securities with the same beta which have different return characteristics. Persistently different return characteristics. So find securities with the same beta, let's say 1.2, and one security has an average return 25%, the other 20%, and the other 10%. Well, this suggests that the capital asset pricing model doesn't fit the data perfectly. Now for me, that's no surprise, because I know that it is a simplification of the world. And that doesn't mean that I'm not going to use the capital asset pricing model, because indeed I will. Because in many cases, it is quite an adequate description of the world. So, let's go to a more complicated model. And it makes sense that if the capital asset pricing model is really simple, because it's only got one source of risk, that the next logical thing to do would be to look at more than one source of risk. So the idea of the arbitrage pricing theory, or the multi-beta CAPM, was to specify more than one risk factor. And what I mean by risk factor is simply something that we get a beta against. So for example, one popular style of model that was introduced in the mid-1980s was a model whereby we looked at certain macroeconomic variables and assessed the security's sensitivity to those macroeconomic variables. Now let's just take one. Let's take inflation, for example. So we could estimate a simple linear regression with more than one factor. So we would regress the security J, on, let's say, the market return and on the inflation rate. So the beta on the market return tells us how the security contributes to the variance of the portfolio, and the beta on the inflation rate tells us the sensitivity of the returns on this particular security to changes in the inflation rate.